Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Alcoholic KOH promotes E2 elimination, dehydrohalogenation, of alkyl halides, removing HX to form alkenes. Moving on to the next step. The compound has a secondary carbon-bearing iodine, Ci. This carbon is bonded to A, a quaternary carbon, bearing cyclobutyl, and to methyls, B, a CH2 group connected to a methylcyclopentane ring with defined stereochemistry, and C, a CH3 group connected to a methylcyclohexane ring with defined stereochemistry. Moving on to the next step. E2 requires an antiperiplanar beta hydrogen. The beta carbons adjacent to C are I, the quaternary carbon on one side. This has no beta H, it is quaternary, so elimination cannot occur in that direction. 2. The CH2 group on the cyclopentane side. This has two beta H atoms, giving one type of alkene toward the cyclopentylmethyl side. 3. The CH3 group on the cyclohexane side. This has one beta H, giving one type of alkene toward the cyclohexyl side. And for the final step, product A, elimination toward CH2 cyclopentane side forms a trisubstituted alkene. The cyclopentane ring carbon bearing the methyl, originally a stereocenter, may or may not remain chiral. The cyclopentane ring methyl stereocenter is retained. Additionally, the cyclohexane-bearing carbon, CH3, retains its stereocenters. Each product from this elimination pathway can exist as stereoisomers due to existing stereocenters in the cyclopentane and cyclohexane portions. Two chiral stereoisomers arise from this pathway. Product B, elimination toward CH3, cyclohexane side forms an alkene. The cyclopentane stereocenter is retained, and the cyclohexane stereocenters are retained. 1,3-dimethylcyclohexane. Two chiral stereoisomers arise from this pathway. Each elimination direction gives two chiral products due to retained stereocenters in the ring systems, and there are two possible directions of elimination, giving 2 + 2 = 4 chiral products total, counting stereoisomers. A. 2 undercounts ignores both elimination directions and their stereoisomers. C. 6 and D. 8 overcount. There are only 2 viable beta carbon sites and limited stereocenters retained per product. Therefore, the correct answer is B. Therefore, the correct answer is option B.